Hello, everyone. Welcome to our webinar, Simplifying Cloud Infrastructure Security with cloudquery, an introduction to structured security analytics for multi-cloud environments. Today's session has no requirements, but having a basic understanding of Osquery and or SQL can certainly be helpful. Our focus today will be on offering an expedited introduction to cloudquery, which is a recently released Osquery extension created and managed by Uptycs. Please feel free to ask questions via the Zoom Q&A function or directly to the Zoom host seen as Uptycs Marketing. Without further ado, I'm going to hand it over to your instructor today, Eric Kaiser.
Hello, everybody. Welcome to Simplifying Cloud Infrastructure Security with cloudquery. I'm happy to be here. My name is Eric. I'm a security engineer at Uptycs. Let me share my screen and we'll get started. All right. So this is a quick introduction to structured security analytics for multi-cloud environments. We're going to go over the agenda quickly, the introduction, which is what we're doing now, cloud security and visibility challenges, the benefits of structured telemetry, a quick overview and intro to Osquery, the same for cloudquery, a demo to give you some idea of what data coming back looks like from cloudquery, and the wrap up. All right, so let's talk about cloud security and observability challenges. According to the SANS 2020 CloudSec survey, the single largest major issue or concern related to cloud computing models is visibility into and control over sensitive data processed, but almost equally as important are consistent security controls and policies across the cloud and on premises, maintaining compliance, rogue use of cloud IT applications that IT doesn't know about, and so on. As the cloud grows, there's this explosion of cloud native services and tools, and visibility across accounts gets ever more difficult, especially in a multi-cloud, hybrid cloud, on-prem environment. Being able to have visibility across all of those data sources is increasingly difficult, or certainly as challenging as each individual environment is, and that only grows as you add more pieces to your environment. As the cloud pegboard survey shows, this is the graph of Amazon namespaces, which roughly correlates to the number of services that they offer. It is loosely correlated because AWS offers about twice that many services, but that number is only growing. Their blog posts announcing new features are growing, and Azure services count and GCP services count are only getting larger as time goes on. So, and the modern attack surface is even larger than that, right? You have your traditional host and VM, endpoints inside your organization. You have the cloud pieces, AWS, Azure, GCP, containers that might be running in production on top of those cloud surfaces, the whole new world of Kubernetes, but even SaaS applications, G Suite, GitHub, where your code lives, Salesforce, Office Online, where your work gets done, and identity providers, Upstream, Okta, Auth0. All of these are increasing or even multiplying your attack surface and therefore your risk. Today's workloads are dynamic, right? DevOps is spinning things up and down, especially with the pandemic and the rise of BYOD. People are bringing their own devices, and it's really just multiplying. So the question becomes, what do you do with all of this data? How do you manage all of and try and control all of these separate pieces? How can you bring them together? Because traditionally, there hasn't been something that's allowed you to look across all of these. So we're here today to talk about structured security analytics. This is a tool suite consisting of a few different pieces. We took the foundation of Osquery for hosts and virtual machine and container visibility and extended that with KubeQuery for container orchestration visibility into Kubernetes, and cloudquery, which is the focus of this talk, for cloud provider visibility, AWS, GCP, and Azure. We're also exploring, although not released yet, but hopefully in the future, SaaS query, again, to return data from your SaaS providers in a structured format, and identity query for the same information also structured from your identity providers. Okay, so why? And separate from the meme that I put on here that horrendously dates me about adding more data so you can do queries, structured security analytics is basically all of your data sources as SQL tables. This allows you and people in your organization to use their existing familiarity, with SQL. It lessens the impact of someone's unfamiliarity with attack surface data sources, right? All of these providers, all of these Kubernetes orchestration, GCP or AWS APIs are all returning data in very different formats. And this allows you to make them look roughly the same, or at least allow you to work with a single language, SQL, across all of those data sources. It also allows you to structure queries similarly across heterogeneous OS and cloud platforms, right? Everything's different, but you can at least use this particular lens to help it look and feel a little bit more similar. So, a quick introduction to Osquery. This is a project that was open sourced by Facebook in 2014. It was originally brought on by, it was eventually brought on by the Linux Foundation in 2019. It is an endpoint agent that supports Mac OS, Linux, and Windows. It also supports FreeBSD and HPAAX, I think, if you have those particular needs in your organization, but really they cover the big three very well. It has low resource utilization and has a built-in watchdog to stop any basically, if you're running a query or the agent's out of control, it has a built-in watchdog that says using too many resources and kills it and restarts it. So you're never going to see a huge impact on your endpoints. And what it does is it structures endpoint telemetry as SQL tables for querying. So it takes OS APIs, it takes log data sources on the endpoint, WMI events on Windows, and bundles it all into a bunch of SQL tables that you can write queries against. Some of your use cases for this, endpoint detection and response, investigation and threat hunting, right, IT compliance and visibility, and audit compliance and visibility. The way that it works, there are two different pieces of Osquery. The main one that gets used, although it's not the one that we'll be demoing today, is Osquery D, which is a background daemon that runs scheduled queries. Osquery I is the command line interactive front end to that, so you can see real-time and interactive queries. Basically, it's a way for you to test out both how Osquery works and for you to write queries and see how they would respond as you go through and are building your use cases. It caches data from events tables, which are real-time events. So process events, file events, open socket events, open network connection events, all get dumped into this on-disk database. And then Osquery itself combines those with other data from the operating system and can ship that off to various destinations. It supports very basic bare bones logging to JSON files on disk. It supports Kafka and Kinesis upstream. You can dump it out to disk and ship it out to Splunk, for example, if that was something you wanted. But it was originally designed and in some cases works best with what's called an upstream Osquery TLS fleet manager. So this is a centralized control unit that receives all of the data from incoming Osquery queries, is able to parse those. You can view results across your entire fleet. And in some cases, you can even send out real-time queries if you want to ask a question of various computers or endpoints in real time. So that brings us to cloudquery. So cloudquery is an open source extension to Osquery. That was announced at Osquery at Scale 2021 by Uptycs, and it extends the SQL-based analytics of Osquery to cloud infrastructure. And currently it supports the big three, which is AWS, GCP, and Azure. And it allows you, as Osquery does, to run both scheduled queries every 500 or 600 seconds, and do real-time queries where you can ask questions directly against the AWS API. So again, some use cases for cloudquery are resource visualization. You can do monitor the configuration of your AWS resources, so you can make sure that they're not drifting from your expected baseline. That allows you to do compliance to make sure that you're meeting the requirements of your environment. And it allows you to do investigation if something goes wrong or you need to figure out why something happened. You can ask direct questions in a structured way and join that data against other data sources such as Osquery. So let's give an example. We're going to take a look at how telemetry provides insights using a combination of the AWS Cloud API and an EC2 virtual machine in an AWS environment. Let's take a look at the following series of events. So we've got a user who's got IAM credentials, and they can log into an AWS account. And they, from a trusted AMI, start an EC2 instance. When booted, this EC2 instance runs an Ubuntu server and mounts an S3 bucket containing sensitive data. The OS software utilities, which are running in the context of an EC2 instance, have access to the data from the S3 bucket. Excuse me. That malicious script, a malicious script launched by the user or an outside attacker invokes a curl command. And that curl executable invokes a DNS lookup of a domain that has reputation and is known to be malicious. It establishes the TCP/IP socket to an IP once that domain lookup has completed. And the curl executable then establishes the HTTPS TLS connection where the JA3 or JARM signature of the connection also has a known reputation to a malicious domain. Once all of that's done, right, the script has run, the curl command has connected to the C3 domain, it's received an IP address, it's made the connection out to that IP address, and it's exfiltrated the data, it goes through and cleans itself up. Okay, and running in the context of the EC2 instance with permissions, it has taken sensitive data from that S3 bucket and exfiltrated it out to a remote destination. So that scenario outlines the possibilities where a malactor with access to credentials or even just access to the EC2 instance is able to exfiltrate information. So for the first part of the interactions in the above scenario, which is the AWS portion of it, cloudquery provides relevant telemetry, okay? And that telemetry includes details about the IAM account, the role, the user, EC2 instance details, AMI details if necessary, the configuration information about the S3 bucket, where that data was stored, including whether or not it was public, whether or not it was sensitive, any user tags, etc. And CloudTrail activity, which captures details about the user connecting with IAM credentials, launching the EC2 instance, and the run of the operating system, which is the part that's actually doing something malicious. For that second part, Osquery, which is running inside the context of that virtual machine, has the ability to capture telemetry at various stages of the attack happening inside the VM. So this is the process events table, which has the ability to capture that the curl command has been invoked because every process that runs is logged to the process events table. It's a real-time table, essentially streaming data, especially if that's being shipped upstream to your SIM or Osquery endpoint. Okay. The process hierarchy in the events table will show you the SSH login, that it was created with a TTY, who logged in, all the way back up to the initd process structure. Okay. When the socket connection is established, the process socket events table will register the necessary information to link. It will have the IP address that was connected to, and that can be enriched upstream with threat intelligence data, IP reputation, domain tools, etc. The DNS events and HTTP events table will provide additional information that could be correlated against domain and HTTP reputation databases, again, domain tools, VirusTotal, that sort of thing. And the URL information, the actual invocation, can be correlated against J3 or JARM reputation databases. Additionally, if the file was copied out of the S3 bucket into somewhere on the Ubuntu virtual machine, the process file events table will have the ability to capture telemetry about the file being copied, being opened, being moved, depending on the location and the folder. So as you can see, there's enough data in Osquery and cloudquery to be able to track the flow of the bad actor all the way from the initial CloudTrail and VPC flow logs down to the actual individual command invocations inside the virtual machine. So that's all well and good. Now the question becomes, what can you cloud query? Right. This is a smattering. It's about a third, I think, of the AWS tables. The EC2 image, the EC2 instance, the EC2 security groups, the IAM groups, policies, roles, the S3 bucket, the CloudWatch alarms, clusters, etc. GCP, same thing. This is half, maybe a third of the resources that you can query in GCP. The compute, disk, image, instance, networks, VPN tunnels if you're hosting it, SQL databases if you're hosting your SQL databases directly in GCP, and the storage buckets similar to the Amazon S3 buckets. That's great. Again, sort of very pie in the sky, like here's some things you can do, but what does this actually look like? What can you, how is this useful, right? So let's talk about S3 bucket compliance. This is from the CIS Amazon Services Benchmark version 1.3.0. Ensure that S3 buckets are configured with block public access and ensure that all S3 buckets employ encryption at rest. Now, blanket applying these policies across your organization, maybe not. You know, there are legitimate reasons for S3 buckets to be publicly accessible if you're hosting software downloads there, for example, but probably not a reason to not have S3 buckets encrypted at rest. So let's take a look at what that query looks like. Let's find out if there are things in compliance. So we are querying from the S3 bucket table. We're looking for the server-side encryption. And if it's set to null, if it's not set to null, that's great. That means it's turned on. Otherwise, we have a problem. And then we have some logic in here to give you a pretty version of what does or doesn't have it enabled and disabled. We'll actually see this when we get to the demo in a couple of minutes. Okay, that's great. That's S3 bucket configuration. Here's a case that isn't linked to a specific benchmark necessarily, but from a BCDR or safety perspective, you probably want to have S3 versioning turned on your S3 buckets. So again, let's check that from the S3 bucket table, let's take a look and make sure that versioning is turned on. Otherwise, we'll send a warning. How about password compliance? Do you know if your AWS IAM users and roles, if your IAM password policy is set up correctly? If you are connecting multiple accounts to AWS, you can query across them to make sure that your password policy is set properly in all of the regions that you have oversight or purview over. There is no trust. We only verify, and this is how we verify, right? Across the minimum password length, password reuse prevention, require lowercase characters, require uppercase characters, set numbers to true, and a password age of less than 90 days, everything's great. Otherwise, something's gone wrong. Now, again, all of this is all well and good, but how does this actually work in practice? Again, Osquery works best when and cloudquery works best when there's a daemon running in the background, running these queries on a schedule every 24 hours, say. You probably want to check your IAM password policy. just for compliance, right? If hopefully there are alerts and other things, which cloudquery can certainly do for you. But an important piece is you need to have a way to aggregate all of these logs. If you've got a seam or a SOAR, great. This can be a piece that plugs into that. If you're looking to get started, Query TLS is a very bare bones upstream Osquery TLS aggregator that can be deployed in AWS as a Lambda function. So you have cloudquery running in a cloudquery instance, in an EC2 instance somewhere, and shipping that data in JSON format to a Lambda function. And that allows you to create rules and alert notifications using the JSON logic project. And it persists that log data to an S3 bucket organized by day. This allows you to set up a minimal logging and alerting infrastructure for cloudquery. You will still have to manually create the query packs for cloudquery, but this is a great way to get started if you're looking for a minimal visibility and alerting infrastructure to get started with cloudquery. All right, so I've talked about a lot of things. Let's actually show you some of those. Let me switch over to my demo environment here.
Eric, we got a question. Maybe you could answer.
Sure. What's the question?
Do I need Osquery to support cloudquery?
Oh, that's a great question. So cloudquery is an extension to Osquery, and it does sort of work best when paired, right? Chocolate and peanut butter, so that you are just sort of adding your data sources together. The short answer is no. There's no requirement to deploy Osquery with cloudquery. Cloudquery comes packaged as a Docker image, and I'm actually going to show you the command invocation for that here. It has basically a very minimal Osquery stub built in. There's about 4 of the 300 original Osquery tables just to support sort of its own minimal bootstrap. And what you can do is just run cloudquery in isolation somewhere. You don't have to deploy Osquery or sort of manage it in the way that you traditionally would. That's a great question. Thanks. Okay, let's take a look at running the Docker command. So we are running, this is a Docker image that you can pull from Docker Hub directly. You need to link the configuration directory, which has your AWS credentials and a place for the actual logs that cloudquery is generating to go. Uptycs cloudquery is just the name of the image from Docker Hub, and we're going to invoke Osquery with the cloudquery extension. So this drops us into the Osquery table, and let's run one of those queries previously that we were showing on the slides here. All right, so we're looking for the server-side encryption, and from the S3 bucket, we're just gonna limit it to our demo environment here. This is an EC2 instance that has permission, that has AWS API permissions. It can take a moment to return because when you are running real-time queries, what is happening is that it is actually going out and querying AWS API directly so that you have the most up-to-date data. Let's actually run another command in parallel. Yes. All right, so there's another instance, and I'm going to do this because it does really can take a moment or two to return that data. Again, this is where the having queries scheduled to run in the background to return that data desynchronizes your need to have questions answered immediately, because you have the questions that have already been answered upstream somewhere else. So you can ask questions of your other data sources. There's the S3 bucket versioning question. Are they turned on? Yes or no? And once one of these returns, we'll go and look at the AWS IAM password policies. Are there any questions in the meantime?
I do have a question. In this scenario where someone may have an AWS organization with multiple child accounts, can cloudquery natively unify all of them into a single logical table?
Yes. So as long as the credentials you've passed to cloudquery have the permissions to read data from all of those accounts, there is a column in almost all of the AWS tables that is the account ID, and you can view data across all of your AWS accounts in a single table in a singular instance. So you're not required to run a cloudquery table, a cloudquery instance across one for each of your AWS accounts. You really only need one as long as it has read permissions. You probably shouldn't be granting write permissions to cloudquery because A, it doesn't have the power to make changes, and B, from a principle of least privilege perspective, you don't want rogue instances running around with read and write access to all of your AWS accounts in one go. All right, so we've gotten data returned from the S3 bucket table here, the name of those 3 buckets, and the status on all of those is okay, which is great because that means that the encryption is turned on all of those. The region code is here. Let's actually take a look at the tables that we have. And that is the, here's all of the AWS account tables, the workspace, the KMS keys, EC2 instances, all of it. I'm going to run that. I know we're kind of coming up on time for a webinar here. I'm going to run that IAM permission query. There's our password policy. And again, so our versioning status has returned, and we have a warning. The versioning is not turned on these buckets. That's expected. We don't have them turned on for exactly these demonstration purposes. And oh, hey, our other query returned as well. Looks like we don't have strong password policies configured, which is a problem. Now, this doesn't return a whole lot of data because of the way in which we've structured the query. We really just wanted a good, bad, insufficient data warning. You can query from the IAM policies table. There's like 8 columns or so that will show you all of the password policies, uppercase, lowercase, all of the rest, set or not. All right, that's all the demo time that we have time for. Let's do a quick recap. So again, cloudquery extends Osquery to deliver data about cloud infrastructure in a structured format. It converts AWS, Azure, and GCP infrastructure and telemetry into SQL tables for querying. It allows you to stream the data in JSON format to an upstream aggregator, which is highly recommended to get the full benefits and the full power. You can certainly log in and do investigation, ask real-time questions, as I just demonstrated, but having that data coming in consistently to somewhere upstream is going to unlock new worlds for you, right? Again, some quick use cases: cloud security investigation, threat hunting, audit and compliance, IT management, all of that to just get a better handle on your infrastructure, right? And again, we're talking about telemetry powered and structured security analytics, Osquery, KubeQuery, cloudquery, and hopefully coming soon, SAS query and identity query, being able to tie all of these disparate sources, applications, pieces of your infrastructure into those SQL structured tables so that you can use the experience that you hopefully already have in-house for that to ask questions and join data from these multiple sources into singular insights. Okay. If you're curious and want to get started, github.com/uptycs/cloudquery and github.com/uptycs/kubequery if you want to take a look at Kubernetes. That's all I have for you today. Are there any other questions?
That's about all the time we have today. Thanks for joining the webinar, and thank you very much, Eric. I encourage everyone to please reach out to marketing@uptycs.com with any further questions. And be sure to star the Cloud Query extension on GitHub for further exploration. That's going to be at github.com/uptycs/cloud query. We will be sending a copy of this session to all registrants. You can access it anytime to continue your learning. Thanks again for joining, everybody. Have an awesome afternoon.